Baller. Okay, welcome to calculus, guys. So we're jumping right in. First lesson starts now. We are talking about limits and continuity. That's our first entire chapter. Now, you guys have seen limits, at least in notation, a little bit. We probably wrote it once or twice last year in pre-calc, but it's something that you've been dealing with. Do you ever remember problems? And remember, if it's pink, it's just think, right? So don't write if it's this bright pink color. You know what? I kind of like the pink, but we'll deal with that. Do you guys remember seeing problems that look like this? As x, bless you, something like this. This is a limit. Like whether we use a word or not, you've all seen limits before. So as we jump into this, we are going to start with 1.1. And in 1.1, we're obviously going to focus on these limits, but we are looking at 1.1, limits with numerical and graphical approaches. So chapter 1, section 1, limits, and I'm going to try to shorthand that a little bit. Limits, we'll just say numerical and graphical. Okay. All this means is we're going to be able to do it a really tedious way on the calculator. That's the numerical approach. But if we know what a graph looks like, which we've spent a ton of time graphing over the last several years, then we'll also have a nice way to think about this. So in our study of calculus, we start with one big idea. I'm pretty sure that you guys have heard me ramble about it multiple times. Anybody remember what I said calculus was about? Slope. Love that. When I think of calculus as a class, like the subject itself, it's just the math of change. That's all it is. How does stuff change? Which is a really important question if you're building or producing or whatever, like millions of applications. So as we're looking at these, we care about the slope of something. If I talk about the slope, though, I'm usually talking about what type of graph. Is it quadratic? Is it a sine function? Is it a line? Lines have slope. Do we all agree on that? Okay, so this is going to seem crazy, but we're not going to draw a graph with a line right off the bat. We need a graph that has a line that touches it somewhere. What do you call a line that only touches one time? A tangent. Geez, look at that. Nice job. So our first little focus today is the slope of a tangent line. Now in the book it says slope of a line tangent to the graph, just so you're aware, but that is much wordier. Slope of a tangent line. That's our first focus. And not going to lie, in one way or another, for the next roughly 4 months, this is our focus. How do you find the slope of a line? Cool. Okay, so we're going to sketch a graph together, and you don't need a nice, wonderful scale or anything. If you want a straight edge, just so you guys are aware, you're always welcome to grab one, take one. Don't take like 50 throughout the year, but I just have them up in this basket here. You guys are welcome to grab it. If you want the graph paper stuff, I'll also put a bunch of that in this box. But I'm not going to wait for perfect graphs unless we need perfect graphs. Anybody want graph paper while I'm throwing them around? Okay. Deal. So we're going to sketch not a line. We're going to graph a crazy function. And it's just going to be kind of like a, I don't know, a cubic looking function. So it does something like this. And it goes for, I'm going to make it smoother because that bugs me. But there it is. There's a lovely curved function. And let's just call this thing f of x. Okay. As we're looking at this function, if I said, what is the slope of that? Do we all agree that that's a strange question? Yeah, it doesn't make sense to talk about it. We need to know where we're looking. So what we're going to do is somewhere in here, and I'm going to try to put it right at the bottom of this bump is where I'm going to put it, is I'm going to mark a spot on the x-axis that we'll just call C. Now, as we're looking at these, I'm going to go ahead and label this point right here. We'll just call it P for point. Okay. Nobody in here can tell me what are the exact coordinates of this point. Not with numbers anyway. But you think we could write this ordered pair with what's on the board here? What do you need for ordered pairs? You need an x and a y value. What x value do you think we're plugging in at point P? C. Okay, so we have the y coordinate. And what function are we plugging this into? Or sorry, we have the x coordinate. I misspoke. So here's the point C, comma. How on earth do we get the y value there? F of C. Love it. Okay, so what we're starting to think about just right off the bat is I want to know what is the slope of the line at point P. But again, do we have a line on the board? No. But Christina saved us, because what are we going to draw here at this point? A tangent line. Now, it's been a while. We only talked about them really briefly in geometry like 3 years ago. What's a tangent line? How many times does it touch? Okay, so is this a tangent? How many times did it touch? Once, but it's not a tangent. When we think about this, and this isn't like a formal definition, it's just a nice way to think of it as a fleeting touch, like just passes right by. So if we take this line, and instead of going straight through it, because I could draw a bunch of them, right? We don't want ambiguity in mathematics. That doesn't help us. Is there a singular line that I could draw that's straight that touches that at one point, but just fleetingly? It touches it and keeps going. So you could try to make it the starting point C, but if we wanted it to be a line, we wouldn't even need a starting point. Is that just barely touch it and then keep rolling? What we have just sketched is our tangent line at point P. This guy right here, this yellow one, orange, whatever color this is, that's our tangent line. So let's go ahead and put that. Now, we don't have actual numbers, but we've dealt with slope a lot. To be able to find the slope of a line, how many points do you need? 2. How many points do we have? We only have 1, right? Only 1 written down. Are there more points on this line, though? For sure. So I'm going to draw a few things. I'm going to do them in pink until it's time for you to write something. But let's just think about how these work. If I pick any other arbitrary point on this graph, and I like to pick a point over here, and I'm just going to say this is point Q. Could we write that ordered pair if, I don't know, we're going to have to think about where we want to put this. Let's say this happens at some arbitrary x value. We'll just call it x. Could you tell me that ordered pair at point Q? X, comma, f of x. Or it could be f of r if we used r, right? So we have this lovely point. X, comma, f of x. Okay. I see a bunch of people writing. You're cool if you're already writing it, but we're going to make this ugly for a moment. How many points do I have on my graph now? Could we find the slope through those 2 points? Now, here's where the changes are going to start happening. I'm going to go ahead and draw that as a dashed line. I'll have to dash it after the fact. But if we have a lovely dashed line right here, that now passes through 2 points. Could we conceivably find the slope of this? I think so. Now, this is no longer a tangent line. Anybody recall what one that touches twice in this little area is called? Starts with an S. Slope's a good idea. Not quite, though. We're going to refer to this one right here as a secant line. And certainly related to tangents and secants from the unit circle, but we are not doing any trig. There's no trig happening. I would draw it, but if you want to wait, I'm going to move it. Like, it will move. Okay. If I wanted to find the slope of this line, and I want to, but here's what I want. You guys at your groups, I want you to find me the slope of that pink line. So I'm going to write this down, and just to make it a little bit nicer, instead of the slope of the pink line, I'm just going to use what letter for slope normally? M, and I'm asking for the slope of the secant or the tangent? The secant. So I should have gone blue, but that's okay. I want you guys to spend a minute, and I'm just going to use a subscript. I want you to find me the slope of that secant line. You're not going to give me a number, but you'll give me a nice little expression. Give you about 60 seconds, talk it out with your neighbors. Between these 2 points, find me the slope. No numbers. It's going to look kind of ugly for a second. 60 seconds starts meow. So Abijah, help me find the slope here. What is slope first? Let's go quick. What's the most basic way that you think about slope? Rise over run. Awesome. Is it more natural to put the bigger y value on first or second? Like first is what I would do. What's the bigger y value we have? F of x. So if I'm trying to find the slope, I would just simply take f of x, the y value right here. What would I subtract from that? Ooh, I'd say it again. F of c. Does that give me my change in the y value? For sure. Now that's a rise. What else do we need? The run. And we'll just call that x minus what? Indeed. And I don't know why. Is this frozen? No. Oh, thank goodness. So x minus c. Do we all agree and are comfortable with the fact that, okay, yeah, that slope, that's how we calculate it. There's no numbers, but that's fine. Now the calculus is going to happen. Point Q was completely arbitrary. We want the slope at P, and we just said, oh, another point exists. Is that secant line and the tangent line the same slope? The dashed line and the solid line, they're definitely not parallel, right? They're not the same slope. But I just kind of randomly picked a Q value. Here's where it's going to get a little bit ugly, and this is why I was waiting or telling you to wait. Could I pick a closer value instead of going all the way over here? And I'm just going to pretend like I hadn't picked any of those. Could I have picked this x value instead? And then if I had done that, it would have corresponded to this. And when we did the exact same process, that would have been my secant line. Everybody cool there? Is that closer to the tangent? Could I get closer to C still? Like this is this far away right now. Could I pick that part so it's really close to it? How close can I get? Infinitely. Now, we're going to use a little bit different language. We're going to say arbitrarily, because as close as you want. Because if you say get this close, I can get closer. And I wouldn't say that's infinite, because infinite is large. If you want the real word, it's infinitesimally. But I'm just arbitrarily. That's easier. Arbitrarily close. So we're going to make that important comment. As we get arbitrarily close, as we get arbitrarily close to x equals c, our secant line becomes a what? Love it. It becomes a tangent line. Now, what we have just discovered has been the focus of mathematics for hundreds of years at this point. Could have been thousands. There's some stuff that probably shouldn't have happened. But we have this. As we get closer and closer to picking that value, we get closer and closer to figuring out what the slope should be and what it is. Now, that is the driving idea behind calculus. And what this really does is it helps us to really lock in and say, hey, what happens to a function as it gets arbitrarily close to something? And that's what we're seeing here. And I know the language is kind of ugly, but the cool part is that in this little thing, if you're comfortable with what we've just done, by moving that Q point closer and closer, we have the idea of a limit ready to rock. So we're going to go ahead, and there's a bunch of small sections here. The idea of a limit. The idea of a limit. Okay. For this, just language-wise, because it's always kind of misleading. If I say the value of a function, like, I don't think I need a function, but if you need me to draw one, I can. If we had a function, I said, what's the value of the function? Am I asking you for the x value or for the y value? So let's check. Don't sketch this. I'm just going to graph one here. Let's say that here's f of x, and sure, I should have done the point second. That would have been a better idea. Let's have this function. And here's the point for 3. If I said, what's the value of the function at this point? Is it more natural for you to say 4? Or is it more natural to say 3? I want to go with 3. The input is 4, but the function spits out a 3. The value of the function is 3. Okay, so when we're thinking about the idea of a limit, in simplest terms, we're just going to say that this is the y value, and it could be any other variable, just the output is what we're really focusing on. But the y value, a function approaches as x gets not infinitely close. What was that word we're going to use? Arbitrarily close to, and we're going to say x equals c, where c is just any number. Okay. Lovely. Do we want to do calculator stuff first or graphical stuff first? Do you have a preference? Graphical? Deal. Cool. So we have two nice interpretations, and the graphing one is what I certainly prefer. We only have till 05 today. I lied. I'm sorry that I asked, and that it now seems like it doesn't matter. We're going to take the numerical approach so that we can find a nice spot to pause, and we'll finish the other one. My bad. I shouldn't have done that. Okay, so check this out. We are going to think about a limit, and we're just going to jump right into an example. So example. We're going to do a numerical limit. What are you looking for, Casey? Come on, just kidding. You're fine, it'll dry. Okay, do we all have our fancy calculators? Awesome. Okay, for this, I'm going to show you guys some really cool stuff. But the very first thing is you're getting that, we're going to say on A, the one that we're solving, and I'm going to write this gigantic, but it's normally just regular size font. We are going to do this. I want us to evaluate this, and I'm going to ask some questions about it before I say it. Let's say it's this value. And then I have this lovely expression here, x squared minus 1 over x minus 1. Okay. You can either internalize this or you can write it, but we need to be able to say it correctly. Anybody think you can say what is written there? Fair. That makes sense. So again, optional. All your notes are kind of optional. You need to write something. You do not have to write every single thing that I write, but I'll try to not write stuff that won't be valuable. Okay, we are going to read this. The limit as, and I'm not going to write the word approaches, but what is x approaching on this? 1. And then whether we have parentheses right here or not, some places do really well with it. On a calculator, you'll have to have those parentheses, but we typically don't when we're writing. This is the limit as x approaches 1 of, what function are we looking at, do you think? The argument of my limit, if you will. X squared minus 1 over x minus 1. Now, we will look graphically at this problem as well, but we're going to knock this out on our calculators. So right off the bat, we're going to get some practice. The first thing, does anybody know what this graph looks like? Yeah, me neither. It's kind of ugly. There's a hole in it. I can tell that much. But let me grab my calculator. And if we wanted to see stuff on our calculator or evaluate it, where would you type a function in on a TI-84, the yellow ones? In y equals. Where do we find that y equals on this bad boy? Okay, so diamond F1. There's a y equals written here. Okay, when we do this, it shows up. Yours may be blank. It may not be. If it is not blank, you can clear it. Just select it and clear it. What's our function? X squared minus 1 over x minus 1. So I'm going to type this in, and I want the first person that sees the mistake I'm making, I'll zoom in on it so you can see it. I want you to tell me the mistake that I'm making. X squared minus 1 over x minus 1. Is this going to give me the right thing? What is this going to do? So I don't think so. I think this is going to be x squared, just alone, minus a singular fraction that's 1 over x, and then minus 1. If I hit enter, yep, it's awful. How on earth do we fix that? Parentheses. The nice thing about these is you don't have to do anything crazy to insert. I'm just going to go left and right. I'm going to put my parentheses around a numerator. They're always there, whether we do them or not. And do I need parentheses around the denominator? I do. Okay. Again, these calculators are awesome because they can show us whether we've typed it in right. Okay. We're wondering what this function does at what value. Our limit is approaching x equals 1. Can anybody tell me that why there's an issue at x equals 1? It's undefined, right? If I put a 1 in there, it gives me a 0 in the top, which no problem, divided by 0. Can't do it. Does my function actually have a value here? No. And this is where we're really going to focus on the language. When we talked about a limit, and we've only spoke a little bit about them, but do we say, what is the exact value of my function at x equals 1? Or is it just as we get really close to it? Really close, right? We get arbitrarily close. I don't care if that point actually exists. I just need to get as close as I can to it. So if we were to look at this and I want to know the value of it at 1, we're going to do this numerically and graphically with the same example. Back over here, and I lied here. If I want to type stuff in, do you guys remember kind of when you type something in, you can hit enter and then you go to varlink and then you do y variables and it's a mess? You remember typing that in to evaluate functions? So on a TI-84, just in case, this is what it looks like if I have a function typed in, which I do. When we wanted to do like f of 1 and f of 2, what we would do on this one is we had to hit the variables button and we had to go y vars and do all this and we type it in. Okay, on these ones, it's so much nicer. What is my function named as on my calculator? y1. So check it out. I'm going to go back to my home screen. I have a y button on this calculator. I always get goofed up because it feels like it's backwards. Oh, y is right here, right underneath mode. You can also go to the diamond and find the y. It will still work. But as long as I have a blank line, and I had a minus, so it's going to mess me up. Y, what was our function? 1. If I just say y1 of, it knows what I'm talking about. So this, I will limit the number of tedious examples. Anybody need me to? If you need me to repeat calculator stuff, like you should always ask me to repeat stuff if you don't grab it or catch it, but especially calculator stuff, please ask right away. You can ask each other, but you can also ask me because you're probably not alone. Make sense, Lay? So all I did was once I'm here, I just hit the Y button. Y, and then it's Y1. So I just hit 1. Okay, so we are trying to get arbitrarily close to 1. Do we have to get to 1? No, we don't need it at all. Now, if I have this graph, and we're not going to look at it yet, I can approach x equals 1 from the left side, but I can also approach it from the right side. Like I could pick really close to the left or really close to the right. Do we all agree? So give me something. We're going to make a small table, x and f of x, and right smack dab in the middle, and we don't really have to use as many points as I have historically. I'm trying to approach what x value? 1. So if I smack that right in the middle of the table, does this work for my function? What did it make me divide by if I chose 1? 0. So if I can't use it, undefined. I'm not going to have a value here. But that's okay, because we're only getting arbitrarily close to x equals 1. Give me something kind of far away on the left of x equals 1 that we can start at. Something kind of close to 1. I heard 2 different things, but I didn't actually hear any words. I didn't understand you guys. I'm sorry. On the left side, think of a number line, something left of 1 that's kind of close. 0, sure. Okay, what is y1 of 0? I bet it's 1. Is that true? Can we get closer than 0? Give me something closer, and if anybody's confused what I mean when I'm saying closer, this is just for me thinking. Here's 1. 0's over here. Give me something closer on the left side of it. Because it'd be -1 over -1. Which, just to verify, if I do that here, y1 of 0, and I just put parentheses and hit enter, it's 1. Cool. Okay. Well, that's not really that close. And I know that close is really vague because what I consider close, 0 is pretty close to 1. What's way closer? Give me something closer. 0.5. Give me something closer so I only have this many spots. 0.9. What is the value of this function at 0.9? And I want everybody to make sure you can get this on your calculator. First person to get it, shout it out, and we'll all verify. y1 of 0.9 is what we're after. If you don't use parentheses, you're doing it wrong. 0.9? 1.9. Okay, sorry. 1.9. Okay, but we're just going to get in an endless loop here. Is 0.9 really that close to 1? Can we get closer? Give me something closer. 0.99. Can I skip a few spots? Because I'm going to just ask you again, can I get closer again, right? Let's get pretty close. We're within a 10,000th. 0.99999. And if we had time or room to take like 50 values, you could. I don't think we need to. We skipped a few. What is the value of this function at 0.9999? 1.9999? Okay, if we went one more, and I'm not going to make us write it because we're out of space, but if I asked you 0.999999999 and I just got closer, what do you think is going to happen? 1.999999999. That seems pretty natural. We never quite got to x equals 1, but as we get really, really close, what y value does it seemingly get really, really close to from the left? 2. So underneath this, and we won't write this every time, but we'll just say from left, it would seem that the limit as x approaches 1, and we're going to indicate from the left. When you think of left, is that a negative or a positive? Negative. So if we want to write this nice and concise and mathy, I'm going to make that bigger so everybody can see it well. We are taking the limit as x approaches 1 from the left, and somebody said that that was a negative. Here it is. This tells me it's from the left. That little minus sign right here. And then I'm not going to write the whole function. I'm just going to call it f of x for a little bit of time saving. What did it seem to equal? What do we get really close to as we get closer to x equals 1 from the left? It seems like it's 2. Do you guys agree with that? Okay. We've only done half the battle here. If I approach it from the left, that tells me something. Where else do I need to do, though? From the right. So we're only going to probably put 1 point here in my notes if I were you. But if we tried to make it symmetrical, this would be a 2 over here. And if you want to tell me the value, you can. I don't get that close. Could we get closer than 2? I think so. Like we might have 1.9 if we're making it symmetrical. And we might have 1.99. And I'm just getting just as close from the right. Whoa, am I getting just as close from the right or am I wrong? I'm wrong with that one. I'm wrong with the second one as well. 1.9 is closer, but why am I wrong, Dolan? Yeah, I'm a 10th away, right? So I should probably be a 10th away on the other side. What would that give me? 1.1 instead. Sorry about that, guys. Could I get closer than this? Did I lose you on that one? Okay, so I miswrote. If we think about that number line, I had 1 in the middle, and I started at 0, and then I started the same distance 2, and then I went to 0.9, which is like right here. I should have gone to 1.1. That's I had a mistake there. Does that make? Yep. Now we're going from the right, getting arbitrarily close. Absolutely. What would the next one be? 1.1, and it gave me some value. 1.01, and can we get closer still? And let's just use the same one, so we'll go 10 thousandths. We'll go 1.0001. And that value, I actually want you to give me on your calculator. And I'll fill in a couple of these other ones. I don't have them all. But I do know that this one was 2.01. I bet this was 2.10 is my guess. What's this one give me? 2.0001. Okay. What's happening? And I'm going to change color so we can see it clearly. As I approach, from what side am I coming on this green line? From positive, or how about direction? From the right. And I like that you said positive, Matilda, because when we write this, we're just going to say the limit as x approaches 1 from the right. And if left is negative, right must be positive of f of x. What does it seem to get really, really close to as we approach this from the right there? 2. Okay. So for this very first one, here's the little strangest part. We're going to do a few hand type things just to make sure that we can see it. When we talk about limits, here's what we need. In order for these things to exist, which this one does, whatever we approach from the left side, and I'm just going to do it here because it's your left, and I want you guys, not very often I make you physically do it, approach something from the left, use your finger as your line. What happened from the right side? Did it approach a different number? Now, Christina, I like what you're doing because you're putting them here, but all of you guys are kind of doing something like this. Don't touch your fingers. They have to approach the same number. They get arbitrarily close, they don't touch. You don't need to touch your fingers then. They just approach the same value. If they approach the same value, then we can say the left limit existed, we saw it. The right limit existed, we saw it. So therefore, and I'm just going to use those 3 dots here, therefore, the limit as x approaches 1, and if I don't say from the left or the right, it means I'm talking about both of them. Whether I come from the left side or the right side for this function, as I get close, arbitrarily close to 1, what did my function equal? 2. There we are. We're doing calculus at this point. Wildly difficult. Wildly tedious when you have to do tables like this. Do you think we could do it without the table in our calculator? Okay, so just with, I like to use Desmos, but we're going to get practice with these. Okay, so I still have my function stored in my calculator. How on earth do I graph it? Diamond graph, F3. So if we hit diamond F3, and I'm hopeful that our scales are all different, here's what my function actually looks like. Now, you can't see it here because it's infinitely small, but if I try to evaluate it right here where x equals 1, does it exist? There's a hole. Now, I'm going to use Desmos beyond this, or I lied, we'll just use this all the time. If I want to see where my function is, I'm just going to hit F3, and it's going to give me a trace. Graphical, whether you have your calculator or not, is typically easier. It starts me at the point 0, 1. What are we trying to get close to? 2. So let's see here. If I trace and I'm trying to get closer, I'm at 1.1. No, we're trying to get close to 1, aren't we? Yeah. So I'm all the way over here. I'm just hitting right. Notice that my x value is 2.27 right now. As I get closer to 1, what y value do we get close to? Does that seem what our table just did? Yeah. What about as I just spammed left just now? What about as I get closer to 1 from the right side? Does it also get closer and closer to 2? So are we convinced both with the table and the graph that this seemingly, as we get really close, that's what it is? Boom. Easy. Okay. We have 10 minutes, and that means we got 10 minutes to start our very first calc assignment. So that's pretty sweet. My hope is that you guys will come close to finishing like now in class. But your first homework, you will find it waiting for you. Somebody, I don't have a page written. It's going to be like page 90 because we skipped chapter P, the prelim chapter. I'll get you the real page, or somebody will shout the real page here in just a minute. It's chapter 1, section 1, not chapter P.
Is there an online book for help?
But yeah, it's weird. It just paused there. I don't know what happened. For tonight, I'm trying to remember. Do I use comments or do I just edit this? I must just edit this. Okay, today is 8/21/26. Okay, and let's see. We did 1.1. Do I need to tell you what we did in class, or can I just tell you homework 1.1? Okay, homework 1.1. Anybody have the page number for me? 86, thank you. Okay, this weekend, and maybe right now, I want you guys to do problems 7, 9, 11, and 17 through 28. And let's see if today's the 21st, 2nd, 3rd, 4th. This is due on Monday. And we'll go ahead and I'll save that here. And then I do want to remind you guys, and I'll freeze that. I lied. We'll come back. If you don't have it, we'll get it here in a second. I'll save this. But I do just want to remind you guys, if you're looking at this and thinking, I don't remember what the hell Holloway said on whatever day, scroll down just a skosh. I will put the chapter 1 solutions manual because I only have chapter 2. Cool. The odds, detailed answers are there. I would encourage get practice with your calculator stuff. Cool. You have about 10 minutes. Probably.